Welcome to your lesson on adding and subtracting rational expressions. We're going to take some notes. You were not provided with a notes page. Please take these notes in your notebook. Let's begin here. Adding and subtracting fractions. All right, you may remember when you have two fractions and you need to add them, the denominator, which is the bottom here, needs to be the same. These denominators are not the same. We have a 5 and a 3. So our goal first is to make these the same, and you think of the lowest common multiple, or the lowest number that both of these can multiply into. That number is 15. 5 goes into 15, so does 3. In order to make 5 become a 15, we have to multiply by 3. So I'm going to multiply this fraction by 3 over 3. The reason I chose 3 over 3 is because 3 divided by 3 is just 1. So if we're multiplying this by 1, we are not changing it. It might change what it looks like, or we're changing its form, but it's still an equivalent expression. All right, and on this side, to make this a 15, we multiply by 5 over 5, because times 5 here will make it 15, and again, this is 1. When you do that multiplication, 3 times 6 is 18, 3 times 5 is 15, 2 times 5 is 10, 3 times 5 is 15. So we've written an equivalent representation of this. It looks different, but it's equivalent because all we did is multiply by 1 on each side. Now you can add these. 18 plus 10 is 28, and we maintain the denominator 15. There's our final answer to this. We're beginning with these basics because they help us understand rational expressions. So now when we move into algebraic form of this kind of work, we have a rational expression now. We have a fraction with this on the bottom, another fraction here. We're adding. Same rules apply. We need this common denominator, like here. Right now, this denominator is not the same. One way to begin to recognize what the common denominator is to look at things and factor them. That's what we've been doing a lot with this unit so far. When you have this, you should factor it. So this, you may remember, is a difference of squares. We have something squared minus something squared. That factors into x minus 5 and x plus 5. This fraction remains the same. Now when you compare the two fractions, you can more clearly see what is needed in one of the denominators to make it the same. This denominator has this piece and this piece. This denominator only has this. So this denominator needs to have this in it so that these denominators are the same. So in order to introduce this factor into this denominator, we're going to multiply this fraction by x minus 5 over x minus 5. It's exactly what we did here. We were introducing an extra factor into this denominator, and we multiply by that version of 1 there. This is 1. So now, after that, we're going to have in this denominator x plus 5 times x minus 5, and we'll have two common denominators. So this one remains the same. On this side here, 2 times x minus 5 is 2 times x, and 2 times minus 5 is 2x minus 10. And then this denominator is written out like this. Now we have a common denominator, and we can just add the numerators across. So 15 plus 2x minus 10. 15 plus 2x minus 10 is really 2x, and then 15 minus 10, which is 5. So that numerator is simplified into this, and the denominator is there. We are done. You also need to remember that there's restrictions. Looking at the denominator, x cannot be 5, x cannot be negative 5, because both of those numbers will create 0 in the denominator. So our restriction, remember to put that line through there, x cannot be an element of this set of numbers. In other words, x cannot be one of those two numbers. All right, let's look at another sample. Here's one that has two fractions. Now we're subtracting. All right, same rule applies though. We need a common denominator, which we do not have. This cannot be factored, neither can this. So we're looking at these right now. In order to make this denominator and this one the same, this one needs to have this in it, and this one needs to have this in it. So check this out. We're going to multiply this side by k plus 7, because then we'll end up with a denominator that has all of that in it, including that k plus 7. And we're going to multiply this side by that, because now we'll have a denominator that has k plus 7 and 2k minus 5 as well. So both denominators now you can see one will be this, one will be this. They'll be the same. So let's multiply that out. On top, k times k is k squared, k times 7 is 7k. Over here, 6 times 2k is 12k, and 6 times negative 5 is negative 30. We still wrote it as two fractions with a minus sign in the middle. Here's our common denominator. Now let's do the combining of these, right? So we're going to do this minus this. Now be careful when the minus sign is here. That minus applies to this piece and this piece. So I'm going to write it like this. So the first numerator minus the second one in parentheses, because that minus will have to affect both of those pieces. And then that common denominator has all collapsed into 1. We've combined the fraction. So now we have k squared, or 7k minus 12k. 7k minus 12k is negative 5k. And minus sign here applied to this negative 30 becomes positive 30 here. And the denominator remains as it is. Let's look at the restrictions. To find the restrictions, we have to set each of these pieces equal to 0, because by setting them equal to 0, we can solve what value of k will create 0. So first one, k plus 7 equals 0. If you solve that, you'll get k equals negative 7. That makes sense. Negative 7 put into here will make this become 0, and then the denominator will be 0, which is what we don't want. Then we set this factor equal to 0. 2k minus 5 equals 0. When you solve that one, imagine moving the 5 over, so positive 5, and then dividing by 2, ends up being 5 over 2. So the two values that x cannot be, crossing that out, are negative 7 and 5 over 2. Both of those values will make the denominator 0. Those are our restrictions. Okay, with those examples in mind, try this one out. This one is very similar to the one we just looked at. So see if you can find the simplified form of that, and then what are the restrictions on it. Okay, let's take a look at the work. You might want to pause the video and compare your work to this. I'm not going to go through every single step here, just kind of quickly. First of all, you're looking at this. Common denominator is going to have this in it and this in it. So that means the first fraction is multiplied by x minus 3 over x minus 3, because that will introduce x minus 3 into this denominator. The second fraction needs an x plus 5 in the denominator, so we're going to multiply the second one by x plus 5 over x plus 5. Now both denominators will be identical. This will be that denominator, that will be that one. Here is your two denominators, and then there's a minus sign again. Be careful with the minus sign. That minus sign is going to apply to all of this. Here's what it becomes: x minus 3 minus 2x minus 10. Combine, you have this. Look at your denominator. Negative 5 and 3 are both restrictions. Next one, next example. Let's do this one together. So here we have this fraction minus this fraction. Again, denominators are not the same. However, I do see this quadratic here that can be factored. So again, anytime factoring is possible, try it. So this part factors into this. Two numbers that multiply make 12 are 4 and 3, but this is a negative 7. So negative 4 times negative 3, and then that's our factored form. Now you look at this denominator. It has an x minus 4, x minus 3. This one has only an x minus 4. So maybe we can turn this denominator to look like this one, and the piece that this one is missing is this. So what are we going to multiply by? X minus 3 over x minus 3. Now this denominator will be identical to this denominator. So follow through on this problem. Let's see if you can get to the right answer, and then I'll reveal the work. Okay, so here we have 11x minus this multiplied here, 6x minus 18. Here's our two common denominators. And then we're going to do a subtraction. Remember, this minus sign applies to this and this. So we do minus and then in parentheses this whole part. Combine the fractions. Now 11x minus 6x is 5x. Minus minus makes a positive 18 here. And there's our form. Restrictions are, oh, I don't have it here. The restrictions are 4 and 3. So it should say x is not an element of the set 4 and 3. The two restrictions, x cannot be 4 and 3. All right, try this one. Let's see how it goes. Here's the solution revealed. Again, we have to factor this one first. This quadratic in factored form is here, x minus 2, x minus 3. And then you notice that this first fraction is missing only the x minus 3 factor. So we multiply the first fraction by x minus 3 over x minus 3. Now the denominators are the same. This times this is written here. The fractions have been combined, plus x, one denominator here. Simplify the top, and you get to this, our two restrictions are x cannot be 2 or 3. Hopefully that worked out for you. This is in many ways not easy. We're combining quadratics and all this algebra, but we've been doing good work in class so far, and you've been keeping up. So keep up the great work. Make sure you understand this, and make sure you also practice this. So the more you practice, the better you get. There is a short practice assignment linked in the calendar that follows this video. Please work on that practice assignment and submit your video notes and practice assignment together as one file to Google Classroom. Thank you and see you soon.